Hi, we're going to talk about the basic derivative rules and how to, or not derivative rules, integral rules, and how to apply them to situations where you might have to integrate. So shared on Google Classroom is a list of all of the integrals. There's a whole page of things that look like this. So you're welcome to add them to note cards, or you can just print out that page or have it accessible. So anytime you have the integral of two different things like this, you really are going to integrate one and then the other using whichever rule that you find. So the very first one that we're going to talk about is going to be a combination of these two. So if I were to break this one down individually, what this would do is say, okay, we want the derivative of 3x to the fifth, and this dx represents that we're going to integrate with respect to x, and then minus the integral of 5x to the ninth dx. So we have two separate integrals here. Using this idea, what it says is if there's a constant out there, I can throw the constant out in front and then integrate here and I'll get the exact same thing. So what that allows us to do here is this 3 and this 5 I can throw out front. So I'll have a 3 times the integral of x to the fifth dx minus 5 times the integral of x to the ninth dx. Then I can go and actually look at those rules. So anytime I have x to any number, so p represents an integer, or it could be a fraction or anything, p represents a numerical exponent. So anytime I have x to the p, this is the integral rule I'm going to follow. So looking at my x to the fifth here, so I would have x to the fifth, so p is 5. So my integral will be x to the 5 plus 1, or x to the 6 over 5 plus 1, which would be 6. Now that 3 out front is still there, 3 times that. Now I'll do the same thing with this one. So x to the 9 plus 1 would be 10 over 9 plus 1, which is 10. And then I still have my 5 times that. Each of these separate ones has plus c for some constant, because if you recall, when we derive a constant, it goes away. So we have to work as if there was a constant there, but instead of putting plus c, I really can just put 1 at the end because the two constants was combined to be 1. And now I'd go ahead and simplify this. So if I imagine 3 is over 1 and 5 is over 1, I can simplify these down, and I end up with x to the 6th over 2 minus x to the 10th over 2 plus c. So this right here would be my integrated form of this equation up here. All right, so that's easy enough when it's a problem like that. So we're going to come back to this one, but we're going to look at the very bottom one for right now because it's very similar. But the problem is that we have a fraction. Well, the only fraction integral that I even have is this one right here. The rest of these have square roots and squares and things, which will come into play for this other one. But right now, the only one I have is 1 over x. Well, that will help us with this one, but not this one. So here's what we do on this. We are going to think of this. We're going to go ahead and throw that 3 out front because we can. So if I move this up, that makes it an x to the negative 4, and that's 100% okay. So we're going to go ahead and break this up. Okay, so plus the integral of 2, which really is a constant and could go out front, but we'll talk about that in a minute. X dx. So if I go and pull those out, so once again we have the 3 out front, we'll have a 2 out front, and this 3 will be out front. So I have x to the negative 1, or next to negative 4, plus, when I take a 2 divided by 2 is 1, so really that doesn't help anything, but we'll talk about what that does. Minus, and when I take the 3 out of this, I'm left with 1 over x dx. So now this one right here follows that rule I just used on that first one. The difference is now I have negative, but that's okay. There was nothing saying p could not be negative. So using that idea, we're going to say, okay, x to the negative 4 plus 1 would be negative 3 over negative 3. And we still have our 3 times out front. Now the derivative of 1, or the integral of 1. So think about it this way. What would I have derived to just get 1? Well, the derivative, the thing that derives to give us 1 is just x. So the integral of just 1 is just x. So I'm going to have plus x, and then I still have that 2 out front. There is an implied right here. It's really like an x to the 0. So x to the 0 plus 1 would be x to the 1 divided by 1. Okay, minus, keep my 3 out. But now the integral of 1 over x, that looks like this one right here, which gives us an ln of x. So using that idea, I will now have ln of x. So simplifying and putting together. So these would go away. This would leave us with a negative 1. So I can say negative x to the negative 3 plus 2x minus 3 ln of x. And then don't forget your constant, your plus c. Oop, you probably couldn't see any of that, but there you go. So if you really wanted to rewrite that first one as a fraction, you could. It would end up being negative 1 over x cubed. That just makes it a integer or a whole number exponent, not negative. And then the rest of this would just stay the same. So depending on the situation, for me, I would accept either one of these. It's whichever one you prefer. A lot of times we will say, look at the form it was in. Since it had x's on the bottom, most likely you want to write your answer like this last one. But for purposes of distance learning here, I'll take either one. All right, and the last one we're going to talk about is this one right here, because it's involved a little bit more. Once again, there's a 6 on top, so I'm going to go and throw that 6 out front, leaving me with a 1 over the square root of 25 minus x squared dx. So now what I'm trying to do is find an integral in here that kind of matches that idea. So right here I have a squared minus x squared, and they have a dx on top, but dx could be at the end, it could be at the 1 up there as well, which I believe is how it's written online there for you. So this one looks most like what we want to do. So if we were to think about this, instead of as a 25 as 5 squared, that would make it a little bit easier. That makes our a 5. So if I were to come over and write it like this, the 6 stays out in front, and then I've got 1 over a. Well, a is this 5 times tan inverse of x over a. Well, once again, a is 5 plus c. All right, so this does require a little bit of simplification with this right here at the beginning. So what this would do is, imagine 6 over 1 times 1 over 5. This would be 6/5 tan inverse of x over 5 plus c. And this right here would be your answer for the integration of this right here. So really, when you're finding integrals, you are trying to find which integration rule these questions match. Integrate accordingly, and don't forget c.